Hi, see you all again in this next video. Today we will study particularly on the electropneumatic processing elements and also some of the important elements of electropneumatic. So the first element that we're going to study today is called relay. So relay is actually an electrically actuated switch, contains a coil and a contactor switch or multiple contactors of changeover contact type. So this is a practically electrically actuated switch that used in electropneumatic. So as we know, electropneumatic is involving electrical and also pneumatic. So when we are having a pneumatic application and you want to control it with a electrical input, so you can consider using a relay. So when the power is applied to relay coil, the coil magnetizes, drawing the contact assembly in. So when you have electrical power supplied to the relay, so the core inside the relay will start to magnetize and it will start to move the elements, okay, because of the electrical power. So relay is actually useful because it only using a small amount of power to control a big um, amount of power. Okay, meaning normally in electropneumatic we will use PLC, which is only maximum having 24 volt to control 240 volt. So it's only using a small amount of power. And relay is used to allow low voltage control system. So like how I say, it's only involving 24 volt. Is considered a low voltage, okay, to switch large current or high voltage. Okay, so we move to the next slide. So processing element and the relay. So you can see, so this is an example of relay that we can see in the normal market. So you have a coil inside is connected to the power. So when the coil is supplied power, electrical power, it will start to magnetize and it will start to move this element nearby to the coil or far from the coil. So when it moves, it will start to switch lanes or start to switch contacts in order to allow a larger current or high voltage to be controlled. So this is a normal E140 circuit, relay circuit used in electropneumatic. So you have a coil here inside. So the coil normally we will name it K1, K2, K3. So depends on the number of coils. So one S3 is a switch attached. So you can attach a switch here, okay, to the connectors. And when the coil is magnetized, it will start to activate the relay. So you can read here. Okay, so normally we will in a relay we will have normally open and also normally closed wires. So you can see here there's a connection. So one side of the connection is connected and one more is open. So based on your flexibility and your circuit design, so you can choose whether you want to make it a normally open or normally closed circuit. Okay, based on that you can use this kind of jumper wires or cables to connect. So you can see here you have few ports 1, 1, 2, 1, 3, 1, 4, 1. So it is having a numbering. So for normally close, or we call it as a NC, so normally we will connect to pin 21 uh, or whatever number that end with 1 connected to the number end with 2. So you have a few connectors or few circuit that you can utilize. And for normally open, we normally will connect in with starting with 1 to pin ending with 4. So like you can see here, so you have 1 4 2 4 3 4. So you can make the connection. Okay, so this is animation, simple animation. Okay, when the relay is off, you can see the contact is on the right hand side. Okay, at number 1. but when it is magnetized, the relay coil is magnetized, you can see the contact key is pulled towards the coil and the contact is moved from 1 to 2. So is generally 1 and 2 will have a different voltage. So when you have this kind of relay actuation, magnetic actuation, so you can switch between the contacts. Okay. Okay, more about relays. So relay has a few functions as a safety device. Okay, so when you are dealing with a high voltage and you are using relay to control it, so since relay is only using a consider low voltage 24 volt, so it can act as a safety device. So you can read here. So high voltage of 240 volt can be switched on through a contactor using relay with low voltage. So you use 24 voltage to control 240 volt, so which is 10 times. Okay, so you can even control a higher voltage, okay, like 512 or higher voltage supply by your electrical supplier. Okay, so high current output can be switched on through contactor using relay with a low current supply to coil, and it can function as a safety control circuit, okay, for emergency power cutoff. So in case there's a electrical short or you have a short circuit, so you can just disconnect your relay to save your old circuit. Okay, so relay in electropneumatic normally used in automation process of switching more than one output simultaneously using relay with a coil and multiple contactors. Okay, so the next element that we're going to see today is a solenoid directional control valve. So it's practically you are having a coil and it is connected to your normally used pneumatic directional control valve, or we call it as DCV. So meaning in a normal pneumatic directional control valve, you need to give a mechanical input or pneumatic input in order to activate the directional control valve. But in a solenoid DCV, so you are using electrical signal generated by the coil to give input to the directional control valve. So that is the function of solenoid DCV. Uh, so direction control valve solenoid operate using electrical signal to control pneumatic valve. Okay, they are used to start, to stop, and to change the direction of the airflow, similar like in the pneumatic system. There are two types of operated of direction control valve using solenoid. So you can directly control the valve, or you can use a pilot or indirect operated method. Okay, so these are some of the symbols of solenoid DCV. So solenoid DCV, normally we will have a coil here, okay, and down here, and you have a button, okay, button, or we call it as manual override. So meaning you give input to the electrical contact or relay, and the relay will use to activate the solenoid. So you need to draw both, and this at the back is indicating is only one-sided. Okay, so it's a single solenoid circuit or directional control valve, and you can even have a double solenoid. Okay, so based on this you will know. So you have a double solenoid with double manual override. So meaning you have two push button to control two relays. Okay, in this direction control valve, and you can have a double pilot operated double solenoid with a double manual drive. So similar like this. So when you have a triangle here, so it's considered you are having a pilot operated joined with your double solenoid. So it depends on your creativity and your design of the system. Okay, you can see here some of the solenoid DCV that we are using in our lab. Okay, so normally it will be like this. So the black part here is the solenoid. So solenoid. So you have two solenoid here. That's why we call it as a double solenoid. and you can even have a single solenoid. Okay, single solenoid. So the return operation is controlled by spring. So this is 5/2, this is 3/2. Okay, with single solenoid. Okay, you can see this simple circuit. So this is a simple typical design of electropneumatic. So one part you are having a pneumatic system. Okay, so pneumatic power component like cylinders with a solenoid valve touch. Okay, instead of a pneumatic directional control valve, you are replacing it with solenoid valve in electropneumatic circuit. So you can have one solenoid or two solenoid, and to control this solenoid valve, you need to have a ladder diagram. So this is a PLC ladder diagram. Okay, based on this, you will control the electric and the pneumatic circuit. Okay, so you have here, so when you have switch 1, you press switch 1, so current will flow from 24 volt to 0 volt. So S1 will be activated. So S1 is here, so will be activated. So when S1 is activated, so your pneumatic directional control valve will change state and your cylinder will extend. Okay, so one is finished. You have two more switches, switch 2 and switch 3. You need to press both to activate this line. So when both inputs is given, S2 will be activated, and this direction control valve will switch lane, switch state, and your cylinder will extend. Okay, and one more, when you have a switch 4 active, you press switch SW4. Okay, S3 will be magnetized the coil, and this will switch state and it will move forward. The cylinder will move forward, and you have a switch here. Okay, it can be a so this kind of switch is similar like your roller valve, but in electrical electropneumatic circuit you are using reed switch, or you can use a sensor. So when it extends, it will eat this LS1. So LS1 is activated, so it will be connected, and solenoid 4 will be activated, magnetized. So it will switch state since the input is given here, and it will start to move back. Okay, so this is a simple electropneumatic circuit. Okay, so this is the connection normally how we are doing. So you can see you have a 4 push button here. Okay, it's connected here. So you have a 24 voltage, and normally we use a red cable to show positive or 24 voltage, and we will use a blue cable to indicate ground. So we will have all the connection here. So based on this, so this is a similar like your pneumatic, so you will control to your cylinders. Okay, but because of the inputs given to from the electrical board, the solenoid will be activated. Okay, so similar here. Okay, so supply and power component in electropneumatic system, the supply and power source is divided into two. Okay, so normally you will have two circuits. Since electropneumatic is having two different systems, so you have a pneumatic system at one side. So pneumatic, we know it is powered by compressed air provided by the compressor. Okay, so this is your first power supply that you need to have in your pneumatic electropneumatic circuit, and the second one is your electrical. So electrical power can be given by AC or DC power supply. uh, so you need to combine the both, and you need to have both the compressor and also AC or DC power supply in your electropneumatic system. Okay, so you cannot use a pneumatic compressor to power electrical, or vice versa. You use electrical to power a pneumatic. It cannot work that way. So you need to, your system must have both. Okay, so normally the symbols we will draw using IEC standard. IEC stands for International Electrotechnical Commission. So it will be on the vertical mode, or you can use a JIC standard, Joint Industry Council standard, which will be horizontal. Okay, so you can use either way. So you have the dots here, so for you to make a connection. Okay, so as we see just now, we have two way of control. So it can be direct control or indirect control. So first we see direct control. So direct control in electro pneumatics is similar like pneumatics. Okay, so your switch is connected directly to the solenoid. Okay, so one by one is a solenoid with connected to the actuator. So when you press this switch, this solenoid will be activated, and your cylinder will extend. Okay, so direct control is actually easier to understand. So you don't, because you are not using any intermediate component to control the actuation, but it also come up with the disadvantages. So you can read here. So advantages of direct control. So the circuit will be simple and easy, so less wiring, and it will be relatively cheap. And the disadvantage of the direct control will be, so remote control. So remote control meaning you are using some intermediate component like a relay, a contactor, or industrial computer or PLC to control. So remote control is not possible, and switching more than one valve at the same time is not possible. So you cannot control two lanes, like, so you have one lane here. So if you have two lanes and you want to control using one coil, so it's not possible. So using direct method. Okay, and latching is not possible, so we will discuss later what is latching, and design will be not flexible. So these are the some of the disadvantage of direct control. Okay, so you can see here it's a direct control. You have a push button here connected to your ladder diagram. When you press the push button, your coil Y, so you have a coil Y here, will be magnetized, and it will switch state, and your cylinder will move forward. So this is for your forward stroke, and for return stroke it's based on spring here. But if you want a return stroke to be controlled by a push button, so you press the push button, coil Y will be um, magnetized or demagnetized, and your cylinder will move backward. So that's for your return stroke. So you can see here the similar thing, um, but this is a control circuit. So similar like how we are controlling our pneumatic circuit using OR logic. OR logic will be either one. So you have push button 1, push button 2. So when you have push button 1 or push button 2 is pressed, you want the coil to be magnetized. So you connect the circuit in parallel, similar like this. So when you have this kind of connection, so either when you you press push button 1 or push button 2, your coil will be magnetized. So if you want to have your OR logic in your electropneumatic ladder diagram, so you need to connect it in parallel. Okay, and if you want a AND logic, so AND logic normally you need to have for both input, so PB1 and PB2. You need to press together in order to magnetize. You just need to connect it in a serial like this. So when you press only push button 1, the line will not be connected. So you need to have both. Okay, so this indicating a AND logic in your electropneumatic. Okay, so direct control of automatic return of a double acting cylinder. Okay, so you can have a switch also at the end. So switch S2. So when you press a push button, your coil will be magnetized. So it will switch state, and your cylinder will start to extend. Once fully extend, it will hit S2. So once it hit S2, so you can have a symbol like this connected. So when this is connected, your Y2 will be actuated, and your cylinder will start to retract. So this is a switch. for you to have a automatic return of double acting cylinder. So similar like in pneumatic, we use roller switch. Here you use reed switch or sensor. Okay, so we have seen the direct method. So we will see indirect control of electropneumatic. So indirect control, similar like in pneumatic, you are using intermediate component like relays, contactors, or PLC. Okay, so it has some advantages and also it has some disadvantages. So if you want to see the advantages, so advantages will be remote control will be possible, switching more than one valve at the same time is possible, and you can have a latching, so flexible design of improvement and development for future, and you can incorporate other logic operations. So these are some of the advantages of indirect method, and some of the disadvantage of sorry, not direct, indirect control. So it will be more complicated because you are involving more components, intermediate components. So more wiring needed. So when it's complicated and more wiring needed, is automatically the cost will be increased. So it might not be flexible for a small industry. Okay, so you can see how indirect control of automatic return of double acting cylinder. So using a double solenoid. So previously we have seen direct method. So similar same circuit, but how indirect method is done. So you have coil Y1 here. So Y1 is here, but initially for direct method is Y1 is connected to directly to push button. But in indirect method you have a coil here separately. So when you press push button 1, so it's connected, coil K1 is actuated. So when this is energized, automatically this will be connected in the line 3 and your Y1 is actuated. So it's indirect. So Y1 is actuated, then your cylinder will move, then S2 is connected. S2 is connected, then when this connection in line 2 is connected, your coil K2 will be magnetized and code K2 will connect this and Y2 will be connected and your cylinder will retract. So this is how an indirect way of controlling your circuit, electropneumatic circuit. Okay, so now we move to latching circuit. So what is latching? So you can see the definition here. Latching is actually a process where relay contact remain on without keeping the relay coil energized. So in other words, it is required something to keep the circuit power for a certain function, even though the push button switch is released to the operation of open position. Okay, meaning, so you have a connection here. When you normally when for you to start a circuit, you need to press a push button, then it will be connected. When you release the push button, since you have a spring inside, your circuit will stop. But in latching, even though you press once and you release the button, it will be connected until you press the stop button. So that is what we call as a latching. That's why they say here, even though a push button switch is released, once you press and you release it, your once your system started, it will be keep on going until you press a stop button. So you, in latching circuit, you will have a start button and stop button. Okay, so latching circuit will be divided into two. One we call as dominant off. So dominant off, if I show in the circuit, so you have two push button here. One is to start the circuit and one is to stop the circuit. So in a dominant of a latching circuit, so you can read here, when you are pressing both PB1 and PB2 at the same time, so you are pressing simultaneously, the if the circuit goes to off position, meaning when you are pressing both, K1 is not energized, meaning that is we are calling as dominant of latching circuit. So meaning you press push button 1, push button 2 at the same time, K1 is not activated, so we call it as dominant of latching circuit. And you have one more, we call it as a latching circuit with dominant on. Similarly, you have a push button 1 and push button 2. Okay, you are pressing together and your relay is energized. So meaning your circuit is in this connection, you are pressing PB1 and PB2 at the same time. When you are doing that, K1 is energized, we call it as dominant on. Okay, so or it's a dominant on latching circuit. So this is what we call as two types of latching circuit. Okay, so oscillating motion of a double acting cylinder forward. Okay, so you this oscillating movement meaning the cylinder is moving back forward and backward continuously until you stop. So you have a stop button, so you start, it will keep on going until you stop. Okay, so how it is possible? So instead of one switch, you have two switch, S1 and S2. So S1 to control return motion, full return motion. S2 is to control full forward motion. Okay, to check. Okay, so similar like in pneumatic, you have two roller switch. Okay, here you have two reed switch or two sensors. Okay, so and this is for your return. So similar, when you extend, S2 will be activated, S1 will be deactivated. So based on that, your circuit will be connected. Okay, so you also can use proximity switches. So this is the symbol of proximity switches. So you can use that in controlling the oscillation, forward and return movement of your cylinders in electropneumatic circuit. Okay, so you can use proximity switches. Proximity switches is actually uh, controlling the circuit by detecting a nearby movement. So you can check this in your previous lecture note. Okay, so they will talk more on the proximity switches based on inductive. Okay, so this will be, so for proximity switches also, for oscillation you need to input from S1 and also S2. Okay, and for final, okay, before we finish today, so we will discuss about control of double acting cylinder using pressure switch. So you have a pressure switch here. Okay, meaning, so when you have a push button input here, so LS1 is connected because it's in the return stroke. K2 is energized. So when K2 is connected, so this is initially connected, K1 will be energized. So when K1 is energized, so it will be connected here and Y1 will be energized. So it will change switch, uh, change state, and your cylinder will start to extend. But you have a pressure switch here. Okay, meaning when your circuit reach a certain pressure, then only your cylinder will start to extend. Okay, so you have a pressure switch. So when the pressure switch is activated, then your cylinder advancement or retraction will be controlled. Okay, so this is some sort like a pressure regulating valve in pneumatic. Okay, so with that I will conclude today. So if you have any question, we can you can ask during the discussion session. So thank you so much. Have a nice day.